Welcome back to EduRev. So today we'll be practicing questions on limit, continuity and differentiability. This chapter is the starting point for calculus and is very important from exam point of view. If you're able to understand all questions discussed in this video, I'm sure you'll be able to crack JEE questions also. The weightage of limits, continuity and differentiability is huge in exams. Almost 3 to 4 questions each year are based on this chapter. I have divided the questions into two parts. The first one contains the questions on limits and the second one contains the questions on continuity and differentiability. So let's begin and let's crack JEE. Type 1 questions, as I said, it's on the topic limits. So let's see question 1. Question 1 states that we need to find the limit for this. Now, we know that when I'm going to write limit of n tending to infinity and 1 by n square plus 2 by n square and so on plus n upon n square, I can take n square as common. So I can write limit is n tending to infinity 1 plus 2 plus 3 plus so on till n, 1 by n square. Now the thing is that this is an AP and we know the summation of AP is n into n plus 1 by 2. So I'm going to write the summation of AP in place of this, that is limit n tends to infinity into n plus 1 by 2n square. Correct? Now n will be cancelled by n and I can take this 2 common, that is half limit n tending to infinity n plus 1 by n. Now this can be written as half limit n tending to infinity 1 plus 1 by n. Now the thing is that when n will tend to infinity, 1 upon 10 will be so small and such a meager number that we can neglect it. Therefore, this will become half limit n tending to infinity 1 plus 0 and this is 1. Therefore, the answer is going to be what? Half. So, the limit of this will be what? Half. I hope you understood this. Let's move on to question number 2. Now question number 2 states that we need to find the limit of the given function. Now just remember one thing, that this is what? Greatest integer function. That is, if I am writing 2.3, it has to be what? 2. Now the function that is given, I can write this function as what? N square plus n plus 1 half minus greatest integer of n square plus n plus 1 half. Now I can also write this function as what? So I'm going to write this function and then you have to tell me how that happened. So it will be n plus half whole square plus 3 by 4 minus under root of n plus half whole square plus 3 by 4 greatest integer. Now this is converted to this as, this is n plus half whole square. That is, if you're going to open it, it will be what? N square plus 1 by 4 plus 2 times of n by 2 plus 3 by 4. So when you're going to solve it, you will get what? This. That is, 2 and 2 will be cancelled. So it will be n square plus n plus 1 by 4 plus 3 by 4 will be what? 1. So when you will open this, you will get n square plus n plus 1. So now you know that I can convert this function into this function, right? So now we have to find the limit of the function that is there. So let's find the limit. That is, I have to find the limit of n tending to infinity of under root of n plus half whole square plus 3 by 4 minus under root of n plus half whole square plus 3 by 4. Now as n is tending to infinity, so n plus half whole square plus 3 by 4 can be written as what? N plus half whole square. Correct? Why? Because n, when n is tending to infinity, then this number is going to be a very, very large number. And we are actually doing what? We are taking the square of that large number. So it will be a very, very huge number. And adding a small amount, that is 3 by 4 to it, just doesn't matter. Alright. So what I'm going to do, I'm going to convert n plus half whole square plus 3 by 4 into this. Alright. So what my limit is going to be, let's find out. So my limit will be limit of n tending to infinity under root of n plus half whole square minus greatest integer of n plus half whole square under root. Now the thing is that when I was taking the greatest integer of n plus half under root whole square, so basically what is happening here is that I want to find out the greatest integer of n plus half whole square under root ka greatest integer, right? So I want to do that, but when I'm going to do this, it will be what? This will get converted to n plus half, right? It will be converted to what? N plus half. But the thing is that this n plus half's greatest integer is going to be what? It's going to be n itself. Because suppose n is what? A number. Let's say it's 3. So 3 plus half's greatest integer is going to be what? 3. Therefore, when we consider the greatest integer, we do not consider the fractional value with it, right? So what I'm going to do is I'm going to convert them. So this will be what? This will be limit of n tending to infinity, n plus half, correct? Because square and under root got cancelled, negative. Now square and under root got cancelled in this too, but it was n plus half greatest integer, which will be what? Which will be n, correct? So n is the integer in this, and that is exactly what I'm going to write. So it will be what? It will be limit n tending to infinity, n plus half minus, this will be n. So n and n got cancelled, so it's limit n tending to infinity half, and limit is what? Half. So I hope you people understood how we found out the limit of this. Now let's move on to the next question. But next question is of type 2, which will be of what? Continuity and differentiability. So let's start with question number 3. Now the question says that we need to consider the function this, that is y equals to mod of x minus 1 plus mod of x minus 2 in the interval 0 to 3. And then we need to discuss the continuity and differentiability of the function in the interval. Now the thing is that what I'm going to do, I'm going to plot these two curves, that is this and this, and then we are going to plot another graph after combining both of them. And then we will actually analyze the graph and see that what is the continuity and differentiability of the function that is given. So let's start with mod of x minus 1. But before mod of x minus 1, let's draw how x minus 1 functions. So this is x-axis, this is y-axis, we all know this. So this is going to be y equals to x minus 1. Correct. And this is going to be what? 1, 0. Now what we need to do is we need to find the function mod of x minus 1. Correct. So let's plot a graph of that. So this is going to be the y-axis and x-axis. And mod of x minus 1 will be, this is going to be what? 1, 0. And this is going to be x minus 1, y equals to. And this is going to be y equals to minus x plus 1. Now how this happened? We were taking the mod of it, that is all the values have to be what? Positive. So we just, you can say, shifted the curve that is below the x-axis towards the positive end, right? And similarly for mod of x minus 2 itself, we will plot a similar curve. That is, if I'm going to plot a curve, it will be what? It will be at point 2. That is 2, 0. So this is going to be y equals to x minus 2. And this is going to be what? Y equals to minus x plus 2. So this is the curve that is for this portion. And this is the curve that is for this portion. But we want to find the graph that combines both of them, right? So now I'm going to draw a graph that is going to combine both of these functions, and then we will see what is the continuity and differentiability of the function. So when I'm going to plot the curve of that function, so this is y and this is x, it will be what? It will be somewhat like this. Correct? So this point has to be 1, 1 and this point has to be 2, 1. Now, the thing is that you can see that this point that is 1, 1 and this point that is 2, 1, they are pointed ends, right? So they are not differentiable at these 2 points. Whereas on all the other points of this curve, they are what? Continuous. Therefore, the option is going to be that they are continuous everywhere and that they are differentiable everywhere except at point what? X equals to 1 and x equals to 2, as you can see in this curve. I hope you understood this. Now let's move on. Question number 4 says that we need to determine the points of discontinuity on the composite function y equals to f of x, given that f of x is 1 upon x minus 1. So in this question, what we are going to do, we know that f of x is nothing but it is 1 upon x minus 1, right? So I can find what is f of x, that is f of x means that in place of x I need to put what? F of x, that will be 1 upon, in place of x it will be 1 upon x minus 1 minus 1, right? So when I'm going to solve this function, it will be 1 upon 1 minus x minus 1 upon x minus 1, and this will be equal to x minus 1 upon 1 minus x plus 1. So this will be equal to x minus 1 upon 2 minus x. So this is what? This is f of x, that is equal to x minus 1 upon 2 minus x. Now just see that in this function at x equals to 2 there is going to be a discontinuity, because at x equals to 2 the denominator is going to be 0. So it will be what? It will be not defined. So the f of x function is going to be not defined. Similarly, when I take f of x will be not defined at what? X equals to 1, because when I substitute x equals to 1, the function is going to be 1 upon 0. So this function will be not defined. Therefore, the end function, that is f of x, will be not defined, or I can say discontinuous at 2 points, that is s equals to 1 and x equals to 2. So the points of discontinuity, the total points of discontinuity will be what? That is option number C, that is 2. So I hope you people understood this. Now let's move on to question number 5. That we have a function and we need to find out where is it continuous and where is it differentiable. So to solve this question, what we are going to do, we will take help from graphs. I'm going to draw graph of y equals to 1 minus x, y equals to 1 plus x and y equals to 2. And then we will see that how the maximum function of all these 3 different functions work, and then finally we will find out where all of them are continuous and differentiable. So the 3 functions that we need to work on is y equals to 1 minus x, y equals to 1 plus x and y equals to 2. Now I'm going to plot these 3 graphs on one pair of x and y itself. So y equals to 1 minus x will be what? When x is 0, y is what? 1. So when x is 0, y is what? 1. Whereas when y is 0, x is 1. So it is 1, 0. So joining these 2 dots is going to give me the plot of what? The plot of y equals to 1 minus x. Similarly, when I'm going to draw a plot for another graph, that is y equals to 1 plus x. Now when x is 0, y is what? 1. So that means this point itself, that is 0, 1. Whereas when y is 0, x is what? Negative of 1. So here, that is negative of 1, 0. So when I'm going to join these 2 dots, I'll get a curve of what? I'll get a graph of y equals to 1 plus x. Similarly, there is one more graph and we are going to draw that. So this is the graph for y equals to 2. Now for y equals to 2, it will be like this. That is, this is nothing but 0, 2. Correct. So now I need to find out the maximum of these 3. So how to find out the maximum of 3? It's very, very simple. Alright, so when I'm moving from minus infinity towards 0, I can see that this blue graph is going to be above all the other two graphs, correct? So that means from minus infinity till this point, this graph is maximum. Whereas from this point, that is y is 2 and x is going to be what? Minus 1. So when y is 2 and x is going to be minus 1, then at this point, from this point actually, y equals to 2 will be the maximum function because it's above all the other two graphs. Then there comes this point, that is y equals to 2 and x equals to what? 1. So here y equals to 2 and x is what? 1. So this is the point of 1 comma 2, correct? So this is the point of 1 comma 2. From 1 comma 2 till infinity, the red curve is going to be the maximum of all the curves. So if I need to draw the plot of this, what is going to happen? It will be this, and these 2 points are going to be what? 1 comma 2, and this point is going to be what? Negative of 1 comma 2. So this is going to be a curve. Now you can see that this graph is actually continuous at all the points, but at 2 points it is non-differentiable. The points are minus 1 comma 2 and 1 comma 2. So now let's check what are the options and let's mark the correct one. But before that, I'm just going to erase this. Alright, so when I look at the options, I could say that what? The first option says that it is continuous at all points. So this is true because our graph, that is this graph, is continuous at all the points. Next is that it is differentiable at all points. We know that this point is false because it's non-differentiable at 2 points, that is minus 1 comma 2 and 1 comma 2. So this is false. Next is that it's non-differentiable at all points except for this. This is false. Why? Because it's actually differentiable at all the points except the 2 points that is given. And the statement that is written, it's entirely different of what this graph depicts. The last one is that it's continuous at all points except at x equals to 1 and x equals to minus 1 where it is discontinuous. But we can see that there is no discontinuity in the graph. Therefore, this is also false. Therefore, the answer of question number 5th is going to be option A itself, that is, it's continuous at all the points. I hope you people understood this. Now you can go to EduRef and attempt all the tests that are given there. You can also unlock all the logged contents, that is documents, videos and tests through EduRef Infinity and ace your exams at less than 80 rupees per month. Thank you.